Imagine an aircraft designed to conquer a 2,000-foot runway, easily carrying a heavy payload over 5,000 kilometers, all without a pit stop. What if I told you Boeing once unleashed a marvel that could have rewritten the rules of tactical transport? Welcome to the world of the Boeing YC-14, the King's Challenger that stepped into the arena with promises of revolutionizing the skies. But why did this groundbreaking aircraft retire prematurely? What secrets lie in its design, and how did NASA's experiments play a role? Join us as we unravel the tale of the YC-14, exploring its innovations, triumphs, and the unforeseen challenges that marked its journey. Let's take a trip back to the intense days of the Vietnam War, where the skies were alive with the roar of fighter jets and the ground trembled beneath the weight of history. Now, you've probably seen those gripping scenes of dogfights and fiery explosions. But there's a side of this story that often goes unnoticed. You see, the Vietnam War wasn't just about flashy air-to-air combat. It became the breeding ground for a whole new era of United States air power. Imagine pilots fighting it out in the skies. And now, we suddenly need schools to teach them all those fancy moves in the air. That's where air combat maneuver tactics come into play, shaping the brains of future flyboys. Indeed, it had a significant impact on the design of the upcoming Air Force fighters. Just think about McDonnell Douglas F-15 and General Dynamics F-16, born from the agony of Vietnam's aerial challenges. And down on the ground, where the mud meets the boots, the war taught us a thing or two about precision. Experience in ground attack missions led to the birth of deadly accurate weapons and the iconic Fairchild A-10 Warthog. Now, here's the plot twist. While we're all mesmerized by the MiGs and napalm on our screens, the real MVP of the war effort was the unsung hero, the USAF transport fleet. These seemingly tedious flights crisscrossing South Vietnam were the lifeline, supplying the stuff that makes wars tick. This is where we will dive into two epic battles, Dien Bien Phu in 1956 and Khe Sanh in 1968. Both complex, both relying on countless factors. But here's the thing. It was the USAF transport fleet that kept the wheels turning, ensuring troops got what they needed to keep the fight alive. Dien Bien Phu in 1956, the French faced defeat because they couldn't supply their troops by air. Fast forward to the US triumph, and what sets them apart? The ability to keep their troops fed, armed, and ready via the air. And while everyone was high-fiving the fighter jets and patting the attack aircraft on the back, the USAF had their thinking caps on about air transport. Sure, the Lockheed C-130 Hercules was doing a darn good job, but why not aim for something even snazzier? The USAF realized in 1968 that they needed a new aircraft for their transportation requirements. They began research. Imagine it as a massive search for the ideal flying workhorse. Now, meet the AMST, short for Advanced Medium Stole Transport. This bad boy was supposed to be Hercules' younger brother, with additional tricks under its sleeve. The AMST could land on shorter strips, carry bigger payloads, and zip through the skies at higher speeds. It was like the superhero version of a transport plane, swooping in to make logistics more efficient than before. Because hey, why should the fast boys have all the shiny, new toys? By 1972, the USAF officially threw down the gauntlet, issuing a requirement for this new aerial maestro, the AMST. And just like that, the wheels were in motion for a transport aircraft that could dance through the air with unparalleled grace, ensuring that the lessons from Vietnam weren't just about battles won or lost, but about the lifelines that kept the war machine humming. The stage was set for a new kind of hero to soar through the skies and redefine how we thought about getting supplies where they needed to be. The USAF had a wish list, and it was all about taking off and landing like a pro, especially in tight spots. They wanted an aircraft with outstanding short takeoff and landing abilities. Think about clearing a 50-foot obstruction with just 2,000 feet of runway and hauling a hefty 14 short tons. To put things in perspective, the trusty old C-130, which was already doing its thing, needed 3,500 feet of runway for a similar feat with a lighter 10-ton cargo. But the USAF dreamt bigger. They wanted this new bird to carry more massive vehicles, like the Army's M109 155mm and M110 203mm self-propelled howitzers. And they were eyeing faster speeds, thanks to jet propulsion. Crunching the numbers, they figured this new kid on the block could be more than twice as efficient in ton per mile compared to the C-130. It was like upgrading from a trusty sedan to a supersonic sports car. In November 1972, the competition heated up, narrowing down to two heavyweights, Boeing and McDonnell Douglas. Both were tasked to whip up prototypes, and the stakes were high. The potential jackpot: replacing the entire Hercules fleet and scoring big in export sales. The aviation world held its breath as the stage was set for a showdown that would redefine the skies. Boeing, a key player in this endeavor, delved into various high-lift aircraft configurations as part of the program. Drawing on their experience, Boeing had previously proposed an underwing externally blown flap solution for the Lockheed C-5 Galaxy competition. They also demonstrated prowess in modifying their Boeing 747, turning a losing entry into a winning adaptation. The Boeing 707 prototype, known as the Boeing 367 and 80, had undergone studies incorporating extensive leading and trailing edge devices using blown flaps. Within the TAI studies, Boeing revisited these mechanisms, exploring options like boundary layer control. However, none of these designs seemed to capture Boeing's imagination. And now for a brilliant idea from the engineers at Boeing. They had read about NASA's earlier powered lift experiments involving externally blown flaps and an original idea known as USB, or upper surface blowing. In the USB system, the engine is positioned over the wing's top surface, directing jet exhaust over the flaps. The coanda effect then causes the exhaust to adhere to the flaps and curve down toward the ground when lowered. Intrigued, Boeing dug into NASA's half-span upper surface blowing research conducted in the Langley 12-foot tunnel. Preliminary results from NASA indicated that the USB system was as effective as other previously explored concepts. Boeing wasted no time and swiftly built wind tunnel models to validate the NASA data, aligning the layouts with their own designs. By the end of 1971, several models were actively under scrutiny, setting the stage for Boeing's foray into groundbreaking aircraft configurations that would shape the future of tactical transport. Now, let's talk engines. Boeing made a slick move, picking the General Electric CF6 M50. Each of these powerhouses churned out a whopping 51,000 pound-pounds of thrust. This was a fresh design, a hotshot that Boeing was eyeing for their other projects. Spoiler alert. It even found its way into some Boeing 747 airliners and became the USAF's F-103. But the real magic happened when Boeing strapped on these engines with colossal thrust reversers. The YC-14 could stop on a dime in a jaw-droppingly short distance. It's like slamming the brakes on a sports car, but in midair. In January 1972, the United States Air Force set the stage for a groundbreaking development by issuing a request for proposal, or RFP, that sought to redefine tactical transport aircraft. The challenge presented in the RFP was ambitious: design an aircraft capable of operating into a semi-prepared field with a mere 2,000-foot runway, covering a distance of 500 nautical miles with a substantial 27,000-pound payload in both directions, all without the need for refueling. To put this in context, a similar payload on the C-130 of the era needed nearly twice as much runway length. With the high stakes, 5 companies rose to the occasion, and in March 1972, Boeing unveiled the Model 953. Following a down select in November 1972, development contracts for 2 prototypes each were obtained by Boeing and McDonnell Douglas, who emerged as the leading contenders as the competition continued. Throughout this period, wind tunnel tests remained a critical component of the development process. Boeing's engineers, eager to explore innovative solutions, revisited NASA's USB program. John K. Wimpress, representing Boeing, sought updates from NASA's Langley facility in November, where Joe Johnson and Dudley Hammond presented data validating the high-lift performance outlined in Boeing's proposal. By December 1975, a crucial collaboration unfolded between Boeing and NASA Langley, resulting in a contract for a full-scale USB testbed. A full-scale USB testbed is a complete model of the aircraft's wing and propulsion system developed to test and evaluate the performance of the upper surface blowing technology, which is a propulsion system designed for airplanes. This testbed, located at Boeing's Tulalip facility, featured a 1/4 scale wing, a JT-15D engine, and a partial fuselage. NASA Langley honed in on the effectiveness of the D-shaped nozzle, directing jet flow over the wing's upper surface and the associated sound levels, aligning with NASA's broader aerodynamics research. However, the journey was not without hurdles. 2 significant issues surfaced during testing. The first involved air circulation around the wing at low speeds near the ground, impacting the jet flows spread through the nozzle. Boeing's solution was the introduction of vortex generators on the wing's upper surface, retracting when the flap exceeded 30 degrees. The second challenge emerged from the initial positioning of the tail surfaces, which interfered with airflow during USB operations. Boeing addressed this by introducing a new tail with a more vertical profile, enhancing control effectiveness. Despite these challenges, the collaborative efforts between Boeing and NASA Langley paved the way for a revolutionary aircraft design. The USB system, marked by its ability to direct jet exhaust over the flaps, showcased its potential to redefine short takeoff and landing capabilities. The Boeing Model 953, born out of this ultra-careful research and testing, was ready to challenge the norms and set new standards in the realm of tactical transport aircraft. Sure, the YC-14 took its sweet time to hit the runway, making its debut flight in August 1976, a year after its McDonnell Douglas rival. But when it did, boy, did it make an entrance. With just an 800-foot takeoff roll, it showed off its flying prowess from day one. It could rocket off the ground and climb at a mind-blowing 6,000 feet per minute. That's more than 3 times the ascent rate of the trusty old C-130 variants we had in service. But that's not all. When it came to putting its wheels back on the tarmac, the YC-14 was a showstopper. The shortest landing recorded during its flight tests was a jaw-dropping 387 feet. And get this, that was with a 21-knot headwind, making it a remarkable feat, even for a heavyweight like the YC-14. In calm conditions, the average landing distance was a mere 800 feet. Now let's talk about its reverse game. Thanks to some nifty deflection directing airflow over the wings, this beast could back up like a pro. The minimum landing speed, just 68 miles per hour. And when it hit the gas, it cruised at a cool 504 miles per hour at 38,000 feet. And as for its cargo carrying skills, the YC-14 had big plans. It was set to handle a whopping 31,400 kilograms of payload. For short takeoff and landing operations, it could still manage a hefty 12,300 kilograms or a bunch of 150 paratroopers jumping out to make an entrance. Now, here's where things get interesting. Just when you thought the YC-14 had shown off all its tricks, the bigwigs at the Air Force threw in a curveball. They wanted to see if this marvel could handle something heavier, an M60A2 battle tank weighing in at a whopping 49,500 kilograms. And the YC-14 said, "Sure thing." It loaded that tank in less than 2 minutes, proving that when it came to heavy lifting, the YC-14 was a beast in a league of its own. Now, we're all familiar with the sleek glass cockpits of today's planes, but back in the YC-14 days, Boeing was practically giving us a sneak peek into the future. Sure, this revolutionary aircraft had its fair share of teething problems. Flight testing revealed a drag issue that wasn't anticipated, but Boeing didn't flinch. They threw on some vortex generators on the wings, and the problem was solved. It's almost unbelievable that this was the only hiccup in the YC-14's journey. By 1977, the YC-14 had aced its trials with flying colors. 2 of these bad boys even went on a world tour, strutting their stuff to captivate the interest of NATO air forces. Boeing was on the marketing front line, and there was a buzz of excitement in the air. But just when things seemed rosy for Boeing's innovative transport aircraft, a curveball came their way. The USAF had shifted gears in their priorities. The urgent need to replace the C-130, born out of the Vietnam era, had gone down. The C-130 still had plenty of tricks up its sleeve, and suddenly the YC-14 and its rival, the YC-15, found themselves facing a change in the winds of military preference. The YC-14, with all its groundbreaking features, was left hanging in the balance of shifting priorities. The aircraft that promised to redefine transport had to face the harsh reality that sometimes, even the most innovative creations must yield to the ever-evolving tides of military strategy. Now, fast forward to the present day, and you'd be surprised to know that people are still ordering new versions of the C-130. It has established itself as a timeless classic, proving its worth even in the modern day. But let's rewind a bit. The USAF, after the Vietnam War, shifted their attention to strategic transport missions. The aftermath of the Vietnam War saw a boom in the market for contract air transport services. a lifeline that had significantly boosted the USAF's capabilities. Private companies were flourishing, obtaining numerous contracts. However, as the US wrapped up its involvement in Southeast Asia, these contracts dried up and the private fleets faced a mass exodus. A formidable aircraft leaving its imprint was the Lockheed C-5 Galaxy. As a workhorse for strategic lift, the Lockheed C-1 41 Star Lifter was capable of very heavy lifting. These babies, though solid in design, had clocked in more hours than initially planned, calling for extensive life extension programs. This is where the USAF had an inspirational moment. They envisioned something that sat between the AMST design and the colossal C-5 Galaxy. Imagine an aircraft capable of rough field short takeoff and landing conditions, but with the added twist of covering greater distances while carrying heavier loads. But this is where the YC-14's tale takes an unexpected turn. Despite its resounding success in surpassing expectations, it found itself in a bit of a pickle. The USAF decided to pull the plug on the AMST program in December 1979. The YC-14, with all its demonstrated potential, suddenly became a relic of what could have been, a victim of the ever-shifting winds of military priorities. The YC-14 is a tribute to what might have been. It is undoubtedly one of the greatest aircraft designs that was never given the opportunity to see actual duty. The promise it showed was immense, suggesting it could have been a stellar transport aircraft. Alas, fate had other plans, and the two YC-14s were retired. However, their story doesn't end there. One proudly graces the Pima Air Museum in Arizona, a silent reminder of the aircraft that almost reshaped the skies. The other sits in quiet repose at the USAF's Davis-Monthan Boneyard, a resting place for retired aircraft with tales to tell. Now, here's a fact. Just a year after the YC-14 took to the skies, the Soviet Antonov Bureau introduced the A-72. Given the uncanny resemblance, especially with their over-wing engines, whispers of espionage have fluttered in the air. Some allege that the A-72, NATO designated as Kola, might have been a result of Soviet sneakiness. While the similarities are striking, the A-72 is a lighter aircraft, with about a third of the YC-14's maximum capability. Was it a case of espionage? Or did the Antonov Bureau merely find inspiration in Boeing's initial design proposals, which weren't exactly state secrets? The A-72 and its various versions are still soaring through the skies today, earning a solid reputation. Perhaps the Antonov Bureau simply thought the overwing scheme was a darn good idea. So, while the YC-14 may not have soared in the skies as intended, it might have left an unspoken legacy. The A-72, with its own success story, could be seen as a distant echo of the Boeing YC-14, proof that even when grounded, a design can ripple through time, influencing the aircraft that come after. And so, the YC-14, despite its retirement, may have left a mark on the clouds after all.